Lesson 81, Graphical Solutions, Inconsistent Equations, and Dependent Equations. All right, so we have already learned how to solve for a system of equations using the substitution method and using the elimination method, okay? So we use substitution, and we have used elimination. My pen is not wanting to do right for some reason. I wonder if I left touch on. Nope, it was off. All right, now we're going to learn another method called graphing. Graphing is the easiest of all of the methods. Super, super, super easy because you solve it just using your eyeballs. There's no math involved. But it is important that you remember how to read the y-intercept format of your, or the slope-intercept format of your system of equations. So you have y equals mx plus b. So you have to remember that m is your slope, that b is your constant of change, or it's also going to be the value for y when x is 0, and that's where you're going to put your first point. Okay, so we are given this system of equations, and what we're going to do is we're going to look at each one of these systems, or it's a system with two functions. We're going to look at each one of these, and we are going to graph a line for each one, and where they intersect, that is going to be our ordered pair. So instead of solving using substitution or elimination to find our ordered pair, we are going to find the point of intersection, and that is our ordered pair. Okay? So let us begin by, first of all, let's make a graph. You know what? Let's do some graph paper. Let me get some graph paper in here. Here we go. All right, now we have some graph paper. We can go ahead, and I'm going to make this just a little bit larger so we can see it better. There we go. That works. So I'm going to draw a graph for us. Like that, straighten up. There we go. And there we go. All right. So we are given these two systems, and these systems are y equals x plus 1 and y equals, actually I'm going to do that in a different color so you can see it better. I'm going to do this in red. So y equals negative 2x plus 4. Let's go back to blue. Let's draw the line for x plus 1. So here's what we have to do in order to draw that line. We have to find our slope. And our slope, we always know we have a 1 in front of the x. It's just invisible. Make a whole number fraction, it's 1 over 1. All right, the slope of the line is rise over run, so that's your y over your x, right? That's your slope. So we're going to move up 1 and over 1 for x. That's going to be the slope of the line. But our point, if we put in x is 0, we know that y is going to be 1. So our first point, x is 0, y is positive 1, is right there. Okay, and then our rise and run is up 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. That's our line. And we're just going to draw our line right through that, right? Okay, now let's switch our color and let's do this line. And this line is negative 2x plus 4. We know that if x is 0, y is going to be a positive 4. So if x is 0, we go 1, 2, 3, positive 4. Right there. Okay. Now we have to look at the slope of our line, which is negative 2 over 1. So that's down 1 over 1. Down 1 over 1. So, I'm sorry, down 2 over 1. So down 2 1, 2 over 1, right there, down 2 over 1. So this is our line right here. And where they are intersecting, that is 1 on the x-axis and positive 2 on the y-axis. So our y-intercept is 1, or not our y-intercept, but our ordered pair for this system of equations is going to be 1, 2. And we didn't have to do any math. We just had to understand what we were seeing in our equations right here. And we graphed our pair very easily by graphing the first line, graphing the second line, and then where they intersected, we had our pair. And we just needed to label that. All right? We understand where we are? Okay. Now, if you use colors, that'll be a lot easier. You won't have to label the line. You could still come in here and label it y equals negative 2x plus 4, and then switch over to the other color and say y equals x plus 1. And then you could put this in any color, I don't care. But you do need to label the line with the color of the line, just to make it clear. All right. So let's move on to 81.2. Let me draw another. I think I'm going to just do these graphs in black. So let's see. We've got, let's do this line, and then let's do this line. Very good. All right. So we are told, let me use blue for the first line, to solve by graphing y equals 2. Uh-oh, that looks weird. And y equals x. Oh, that looks even weirder. So how are we going to do that? Well, we know that when we see an equation like this for y, that means it doesn't matter what x is. Y is always going to be 2. So if y is always going to be 2, it's going to be right here the entire time. So this is y equals 2. Right there. Graphed. Now we're going to graph y equals x. And all that means is whatever x is, that's what y is. So if x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2. If x is 3, then y is 3. And we draw our line right there. And the point of intersection, let's go ahead and label our line, y equals x. The point of intersection is 1, 2, 1, 2. So that's 2, 2. Right? Everybody see that? Is that clear? That was 81.2, and this was 81.1. Right? That's how we solve to get our ordered pair by graphing. The only problem with that is it can be a little bit imprecise. It's not exact, but the problems in the book typically are set up so that we can get a good answer. So it's going to be a little bit more exact with these manufactured problems. Okay, let's clear the page. And let's do another one. We have, first of all, let's draw our graph. All right, let's label. We have solved by graphing. We have y equals x plus 2. And we have y equals x plus, or I'm sorry, x minus 1. All right, and you know what? I meant to do that in a different color so it was obvious. So let me do that. Y equals x minus 1. All right, let's go back to blue, and we're going to solve y equals x plus 2. So if x is 0, y is positive 2. So if x is 0, this is y. And we again have the invisible 1, so our rise and run is 1 to 1. So up 1 over 1, up 1 over 1, up 1 over 1. There's our line. And let's graph, or not graph, but label it x equal, or y equals x plus 2. Okay? There's that line. All right, so let's change our color and let's do our red line. y equals x minus 1. So if x is 0, y is negative 1, okay? So if x is 0, y is negative 1. So it's right there. And we have 1 over 1. So we have the same rise and run as this one. So up 1 over 1, up 1 over 1, up 1 over 1. You know what? These lines don't intersect. So what does that mean? That means that we have what's considered, well, first of all, these lines are what we call parallel, and that's the symbol for parallel, right? Because they never intersect. So when lines are parallel and they don't intersect, we call that an inconsistent, if I can spell today, inconsistent equations. So that means that they will not cross. That is what an inconsistent equation means. So you need to write down this definition. Inconsistent equations equals parallel, I think I've spelled that wrong, parallel lines. So when you have parallel lines on your graph, you want to label it as an inconsistent equation. All right, and that leads us right into the next section. We have a way to tell, this was 81.3, by the way. In 81.4, we're going to find a way to tell if a system is an inconsistent or they don't share a common solution. So here's how you tell. We typically have these problems solving for y, right? Y equals x plus 2 and y equals x minus 1. Well, logic tells us that if y equals this and y equals this in the same system of equations, then we should be able to do this. X plus 2 equals x minus 1. If y is a constant, then this should be true. All right, so can we do that? If we subtract x from both sides, 2 is not equal to negative 1. So just doing this little bit of math here, we see that this is going to be an inconsistent equation. And that's how you can tell without ever breaking out the graph. All right, just y equals this, y equals this. Okay, well, if y is constant within the same set of equations, then this and this must equal each other as well. So you can line them up just like this and see if it's true. And if it's true, right, if you can get the same answer on both sides, then you can go ahead and graph it and tell me what the ordered pair is, where they intersect. All right, let's do another one. We are going to talk about something called a dependent equation. Do you remember when we discussed equivalent equations? Remember, an equivalent equation looks something like this. Y minus x equals 2. And then we would have 2y minus 2x equals 4. It's pretty obvious that everything in this equation is just multiplied by 2. And if you divide it by 2, you get this equation, right? So if I divide 2y by 2, I get y. If I divide 2x by 2, I get x. And if I divide 4 by 2, I get 2. So it's the same equation. These are equivalent equations. So when we have a pair of equivalent equations, we call them dependent. Dependent equations, if I can spell tonight, equations are the same as equivalent equations. So look for that when you are given two formulas or equations for the line within a system. Look and see if they're equivalent. And if they are equivalent equations, you know that they are also dependent. You're going to want to write that down. And what that means is that they are going to graph right on top of each other. Don't believe me? Let's prove it. We're going to take this set right here. That's 81.5. And we are going to graph it. Okay. And yeah, that's kind of wonky. I'm going to take away some of that. There we go. What I'm going to do is I'm going to rewrite this in different colors. Y minus x equals 2. And I'm going to choose red for the other one. 2y minus 2x equals 4. All right. They are equivalent, but we're going to show that they do graph right on top of each other. So we have to reorder this and solve for y, don't we? So we would add x to both sides, right? So this would be, the blue one would be y equals 2x plus 2. Agreed? Because we added x to both sides. Now we're going to do the red one. And we're going to add 2x to both sides. So that gives us 2y equals 2x plus 4. We divide both sides. We end up with y equals x plus 2 because we divided both sides by 2. So it's the same equation. Solving for y. Same exact equation. So they are going to graph right on top of each other. If we do the blue one, if x is 0, y is going to be 2. Right? 1 over 1. 1 up, 1 over. 1 up, 1 over. 1 up, 1 over. All right, for the red, if x is 0, y is 2. 1 up, 1 over. 1 up, 1 over. 1 up, 1 over. Exactly the same line. Exactly the same line. So look for that. If you have equivalent equations, you're going to want to check it out and see if you do. If you have equivalent equations, they're dependent equations, which means they are just going to be graphed right on top of each other. And you can graph the one line and then label it with both of these. So you could say that that is y minus x equals 2 and 2y minus 2x equals 2. It is both, right? Or you could even say dependent over here, dependent equations, and that would work just fine. And that's all we have for lesson 81. So take your notes, go back, make sure you have all the vocabulary that we have added, and I will see you in lesson 82.